for this video, let's go over 1 and 2 step equations, but now we're going to see fractions. And specifically, we're going to look at what happens if I have, for instance, 2 over 3 x equals 10. And I'm basically encountering a problem where I need to separate 2/3 from x. And you could go about it a couple different ways, but I want to show you the most efficient and quickest way to deal with it, as opposed to just, I don't know, talking about it forever and giving you some long drawn out process. This is going to be a quick version. So let's say I want to separate a fraction from a variable. I'm going to use something called the reciprocal. Let me see if I can actually spell it right. Reciprocal. All right. So for a reciprocal of a fraction, all we have to do is flip the fraction. So we're just going to flip the fraction. So flip fraction. So that means if I have 2/3 and I want the reciprocal, what's the reciprocal? If I flip 2/3, what does it give me? It gives me 3/2. So that's simple enough to understand or actually go through the process of finding the reciprocal. Okay, so that's the first part. Now, what we're going to do is we're actually going to multiply by the reciprocal. Now, I'll show you just a quick version of what's going to happen, and then we'll look deeper into the problem. So if I look back at 2 over 3x equals 10, once again, I'm going to get rid of 2 over 3 on this left side, and I'm going to multiply by the reciprocal. And once again, here's a little trick to look at both sides of the equation. Just draw a line right at the equal sign. There's your left and right side. So now, if I multiply by the reciprocal, if you've seen the other videos of 1-step and 2-step equations, you'll see that we talked about when you cancel with multiplying or dividing, you should end up with 1. So like I want to end up with 1x here, which we would just write as x. And that's actually going to happen if you look at this problem. If I were to multiply, and you could do this a couple different ways, but this is the quickest way. If you have two fractions and you want to multiply, you can actually divide the diagonals. So if I divide 3 and 3, which that was terrible to draw, 3 and 3, 3's are just going to cancel. 3 over 3 is just 1. Same thing with these 2's, they're diagonals. I can divide those. 2 divided by 2 is just 1. So I end up with x equals, and then remember from past videos, or if this is your first one, what we do to one side we have to do to the other because we want to balance our equation. So if I multiplied on the left side by 3 over 2, now I'm going to multiply the right side by 3 over 2. And now let's look at this for a second. So I'll just do it down here. If I want to multiply 10 by 3 halves, or 3 over 2, I could go about this a couple different ways, but what I want to show you is the quickest way and the most efficient way to do this. So let's rewrite 10 as 10 over 1, because we know all whole numbers have an understood denominator of 1. Okay, so 10 over 1 times 3 over 2. Now, the same way we handled this up here, we can also handle these two fractions. When you're multiplying two fractions, the diagonals will divide. Well, you can divide them if they will divide. So, like I can divide 10 and 2. What's 10 divided by 2? It would just be 5. Now, here's the trick you have to remember. If I divide 10 by 2, the question is, where the heck does 5 go? So a quick way to remember this is whatever you get as your quotient, you just replace the bigger number. So replace bigger number. So which one's bigger, 10 or 2? 10. So that's where our 5 is going to go now. And now you just pretty much look for anything else that will divide. 3 and 1 can divide, but it's going to give you 3. And then you just multiply across the top and the bottom. And this 2 down here is going to get replaced with 1. So we're essentially saying 5 times 3, which is 15. Then we're saying 1 times 1, which is 1, so we end up with 15. So x equals 15. Now, if that was a little confusing, we're going to do another one, but I would encourage you to try to do the next example on your own and try to use this method of dividing the diagonals. Especially if you don't have a calculator, this method is going to help you speed the process up. But once again, if you've learned it another way, just do it whatever way is comfortable for you. So let's look at another problem, and I actually need to find the problem we're going to look at. So bear with me. All right. Let's say I have, let's do negative 5 over 6 k, actually negative 6 over 5 k equals 12. Now, all I've really done here to try to throw you off a little bit is add in a negative. But if you can remember your multiplication rules with positive and negative numbers, you should be okay on this. So pause the video, try this, and see what you come up with. So now, once again, we have negative 6 over 5, k equals 12. If we break this to the left and the right side, you'll see that our goal is to separate negative 6 over 5 and k. We need to separate those. So once again, we're going to use the reciprocal. So the question is, okay, if I have negative 6 over 5, which you probably don't have to write this, I'm just doing it to show you the process. If I have negative 6 over 5, what's the reciprocal of that? And once again, the reciprocal is just flipping this fraction. So if I flip negative 6 over 5, you can just keep the negative on the outside and flip 6 over 5 to 5 over 6. So I'm going to multiply both sides by negative 5 over 6. Now, also pay attention when you're doing these problems, because a lot of people will leave out this negative. But the reason we need to account for that negative, if I left the negative out, I would basically end up with negative 1k, not 1k. And remember, we want this to cancel. So these two are going to cancel. K comes down by itself. Now we need to balance the equation. So what we do to one side, we're also going to do to this other side. So now, all I really did here was add in this negative, and here's what I would do if I were you. I would take 12 over 1, rewrite that as a fraction, then 5 over 6, and write that as a fraction. Now, the reason I didn't carry the negative over is because I can deal with this negative before I even do the problem. 12 is a positive number. Negative 5 over 6 is a negative. So what's a positive times a negative going to give me for my answer? It's a negative. So I can just carry that over, and it's in my answer. And now when I do all this math over here, I don't have to worry about the negative confusing me. I can just bring it over to the answer and then do the problem separately. All right, so now let's look at our diagonals. So our diagonals would be 12 and 6 and 1 and 5. Which one of those would divide? Actually, both of them do, but which one divides to give me an actual answer that will change? It'd be 12 and 6. 12 and 6 will divide. So what's 12 divided by 6? It'd be 2. So now the question you're going to have to get used to answering is, where do I put that 2? Should it replace the 12 or the 6? And the answer is, it's the bigger number. So it's going to replace the 12. And now we just multiply across the top and the bottom. So 2 times 5 equals 10. And then 1 times, now there's a 1 here, that's going to equal 1. So our actual answer is k equals negative 10. So now let's do one more just to look at a two-step equation. The good thing for you is the two-step and the one-step equations are pretty straightforward with fractions. So I think give this one a shot, and I think a lot of you will be able to go ahead and crank this one out. So let's say 3 over 5x plus 22 equals 28. Now, if you haven't once again seen the video that just covers two-step equations with no fractions, I would go back and watch that if you're unfamiliar with two-step equations. So here's our first step. We're going to look at both sides of the equation. X is on the left, so we want to keep X on the left, and we're going to try to get X by itself. So 3 over 5 needs to move, and 22 needs to move. So then the question becomes, okay, what's happening between X and 3 over 5, and then X and 22? Now, X and 3 over 5 are multiplied, so we know that we're going to use the reciprocal to get rid of that. X and 22, there's adding, so we know we're going to use subtraction to get rid of that. So now the question is, which one do we do first? And there's no wrong answer, but there is one way that's easier. This is a case where we're going to add and subtract first, then we'll do the multiplication second. And here's why. If this were rewritten as 3x plus 22 all over 5 equals 28, then we would have to get rid of this 5 on the bottom first. But there's not one big fraction in this top equation, so that's why we're going to add and subtract first, then we'll multiply. So let's crank that out real quick. So we're going to subtract 22 to both sides. 3 over 5x comes down. It's equal to 28 minus 22, which would be 6. So now we've done our first step. Here's our second step. So this was step 1. Now we're on step 2. And the first thing we did was add and subtract. We did subtraction. Now we're going to multiply. And we're going to multiply by something very specific to get rid of 3 over 5. Since 3 over 5 is a fraction, we're going to multiply by its reciprocal. And once again, reciprocal just means flip 3 over 5. So we would flip that to 5 over 3, and we're going to multiply that on both sides. Now, the good thing is this left side cancels and gives me 1x, or just x. And now once again, take this and see if you can write it out and divide the diagonals. Because once again, with these numbers, it's not that tricky. I mean, as you can see, 6, 5, and 3, they're not super big numbers. But if I gave you really big numbers, you wouldn't want to multiply all this out by hand. You'd want to divide the diagonals because it's a lot simpler. So let's change 6 to 6 over 1 times 5 over 3. Now, once again, we're multiplying, and if you multiply two fractions, the diagonals will divide. And the diagonals that I would want to divide are 6 and 3. What's 6 divided by 3? That would be 2. And the 2 is going to replace the bigger number. Then everything that's left, as long as there's no more division to do, you can just multiply across the top and the bottom. So 2 times 5 equals 10. 1 times 1 equals 1. So x equals 10. All right. So now, once again, the big takeaway from this video is if you want to get rid of a fraction, let's go back to the very beginning. What was it? Let me find it. All right. So 2 over 3, x equals 10. If you want to separate a fraction from a variable, you multiply by its reciprocal. And the reciprocal of a fraction, you just flip your fraction. All right, so that will help you tremendously with dealing with fractions when you're trying to solve an equation, because most likely you'll see this pop up quite a bit in your classes. Also, remember, if you're multiplying fractions, there is a trick, which is divide your diagonals. Diagonals. Hopefully that's how you spell that. If that's not how you spell that, then fair enough. And I don't think I'm leaving anything else out. So if you have any questions, you can always reach out and I can answer anything that needs to be answered. Diagonals. That's how you spell it, I think. All right. So if you need to reach out and ask me any questions, feel free. And that will be it for this video.